Hello everyone. Our topic is about advances of blockchain security. Blockchain technology is an integration of several techniques. This figure shows the financial transaction process within blockchain. It includes a unique peer-to-peer blockchain data structure, distributed consensus algorithms, cryptography, and automatic script code to program and operate data. It distributes data to every node in the network and does not require any third-party control and maintenance. Our group investigates the topic from an application perspective. At present market, the two most popular applications of blockchain technology are the Bitcoin trading and the Ethereum trading platform import smart contracts combine cryptocurrencies. We choose these two applications as the entry point. Detailed analyze a security vulnerability and the corresponding countermeasures for possible attacks. Regarding to the methodology, we mainly browse the website about our topic, read researches with different backgrounds, share the knowledge we gained from previous steps, and discuss opinions with our group members.
The concept of Bitcoin was originally proposed by Satoshi Nakamoto in 2008. It refers to a cryptocurrency as well as an electronic transaction system where people can make secure transactions without third-party intervention. Built on top of blockchain technologies, transactions in the system are stored in a list of blocks. Asymmetric cryptography and distributed consensus algorithms are used for user security and ledger consistency. This system does not only remove the need for centralized control, but also reduces transaction costs. Anonymity is another appealing feature, which allows users to easily set up accounts without worrying about revealing their true identities. The Bitcoin system has four major characteristics, including decentralization, anonymity, persistency, and auditability. Persistency refers to the fact that invalid transactions can be denied by honest miners and is almost impossible to delete or roll back transaction records once included in the blockchain, while auditability is that the record user account balance via a UTXO model, where transactions can be easily verified and tracked. Technically, Bitcoin operates on a loosely connected P2P network. This allows transactions and other data to be securely stored and verified without the need of any centralized authority. There are three kinds of nodes on the network, namely the miner, full node, and lightweight clients. There are some critical components for the architecture, which are presented as follows. Despite the rapid growth of Bitcoin system, financial market is skeptical about sustainability of Bitcoin. Researchers mainly criticize the lack of governance, economic model, and security privacy issues of the system. The latter point received massive attention in the academic computer science communities, with recent literature featuring a number of reported attacks. The security issues are listed on the slides.
In the Bitcoin transaction, although we don't know who the two sides of the transaction are, we know the address of both parties to the transaction. This hidden danger has led the Bitcoin community to design various mechanisms to protect the privacy of Bitcoin. In the beginning, everyone used the mixing service, which is like a banking intermediary. Through this service, one person's funds can be mixed with others' coins, which confuses the original source of funds. Mixing service can have two modes. The first one is that the user provides a return address, and the mixer sends the user a coin of the same value from different sources. The users can pay with new coin received from the service. The essence of this model is still the user-led payment operation. The second is that the mixer retains funds, loops funds between other addresses, and finally pays the funds to the user's recipient. The essence of this model is that the mixer leads a payment operation. Mixing services typically charge users a commission. It largely provides a source of confusion about the user's payment. But using a mixing service requires absolute trust in the service itself, which itself has the ability to steal user property, so this is also a hidden danger. Now, researchers have proposed a model called ZeroCoin, which enhances the privacy of Bitcoin. It also does not require third parties to intervene. In the ZeroCoin model, everyone can share access to a board which is integrated with the blockchain itself. In order to cast a ZeroCoin, for example, Bob first needs to generate a random coin serial number S, and through a secure commitment framework, the resulting commitment is C. Only S can be known by its own key K. Meanwhile, Bob inserts C and the currency he wants to trade anonymously into the public board. When C has right structure and has the right amount, everyone will accept it. In order to redeem an anonymous coin, Bob must generate a zero-knowledge proof through two statements. The first one is he knows that his commitment is in the commitment set of the public board. The second one is he knows that the key K allows C to unlock S. Bob then uses camouflage to publish his own S and zero-knowledge proofs. The remaining users will verify his zero-knowledge proof and check if S appears in the previous transaction. Once eligible, the user allows Bob to take away the anonymous coins at any location on the public board. In this way, the identity of the user can be hidden.
The smart contract is a user-defined program running on the blockchain, and the consensus protocol set by a network of peers ensures the correctness execution. Till now, the most popular decentralized cryptocurrency platform with smart contract is Ethereum. Compared to Bitcoin only have one transaction in a block, Ethereum can have multiple transactions invoking contracts. One possible vulnerability is transaction ordering dependencies, for short TOD. It may happen when two transactions invoking the same contract. Take a puzzle solver for example. A malicious owner keeps listening to the network. When a user submits a solution, the owner immediately sends a request for updating rewards into zero. Since the miner can decide the order of transactions in a block, the update request can be the first to execute. Therefore, the user will receive zero rewards and the owner will get the solution for free.
In order to eliminate the TOD problem, we need to guarantee that an invocation of a contract code either returns the expected output or fails. From loose research, a guard condition G is imported for each transaction. When G is not true, it means that this transaction may occur a TOD attack. Then, this transaction will be simulated on a testnet. If any threat is detected, a new guarded transaction will be sent with a high gas and get minded before the risky one. At this time, the original transaction will fail and the TOD attack is avoided. Talking to the benefit of the smart contract, as long as the transaction triggered, the contract code cannot be modified and will be automatically executed. This ensures the deal equally proceeded. In Bitcoin, an address can only belong to one single user, while in Ethereum, an address can be shared by different users.
In this paper, we investigated into several applications and their security issues regarding the topic of blockchain. In particular, we talked about Bitcoin and smart contract. As we learned, Bitcoin is a cryptocurrency as well as electronic transaction system where users can make transactions without third-party intervention. However, user privacy and selfish mining are two prominent security issues which can be addressed by zero-coin model and controlling the portion of honest miners against malicious ones, respectively. Next, smart contract as a consensus protocol between peers in the blockchain gained its utmost popularity on the Ethereum platform. One of its most outstanding security issues, the TOD attack. This can be avoided by introducing a simple guard condition.